In this video, we're going to take a look at some basics of strings. And we're doing that here in our files chapter because strings have some unique ways of interacting with files that I want to show you. We'll spend more time on strings later in the chapter that's dedicated to string functions. So let's remember why we wanted to talk about strings. Here's our output from our most recent example program, where we printed out all of the participants in some competition, and they all ran a certain number of miles. So we printed out each person with a number, and then a little bar chart to show how many miles they ran. And we thought we might be able to make it better if we can include, instead of person 1, person 1's actual name. So a name requires multiple characters to store. And something that stores multiple characters is called a string. So here's a quick look at how we can declare a string. We're going to start with the character data type, char. We're going to give it a name. Since we're storing names, we've chosen to call it name. And then we're going to give it a size inside these square brackets before ending our statement with the semicolon. So this whole line creates a string called name with room for 19 characters or less. What we're going to be able to do with that is read in names from our input file, so that instead of having person 1, we'll be able to have George. And instead of person 2, we'll have Carla, so on and so forth. Now we know how to read things in from a file using fscanf. So the only thing that's different about strings is their percent code. Strings have a unique percent code called %s. So if we want to read in a string, we can read in a string token using the percent code %s. Everything else works the same way. We have our file scan format function. We'll read from our input file pointer. We'll read in a string. But the location we want to store it in is now this name variable, which holds more than one character. And printing it out is the same as well. We can print out a string instead of a decimal, instead of a float, and we're going to print from the variable that happens to be a string. So let's take our input file. Here's a copy of it in the slides. We've copied it into Notepad. This one's called names. We're going to read from this file the same way we've read from previous files. We're going to create a new program. We're going to store in our folder. This is our miles example with names, so I'm going to call it miles names. And the purpose of this program is to read from a file and print a bar chart with names. We'll include our standard input-output library and build our main function. So since we're dealing with files, we know we're going to need a file pointer, at least one. We're going to be reading from an input file and printing to an output file, so we're going to create two file pointers, IFP for input file pointer and OFP for output file pointer. We're also going to create our name, and we're just going to copy that line from the slide. This char space name 20 in square brackets creates a string called name with room for 19 characters. And we're also going to need the number of participants and some loop counters for us to work with. Okay, so now we're ready to initialize some of our values. Our input file, we're going to open names.txt. That's the input file that we're working with. It's the one that has the names in it, or the strings. And we want to open that in read mode. We also want to initialize OFP. We're going to open an output file that we can output to, that we want to output in write mode. Then we can start reading in the number of participants. Remember, we want to make our program match our input file and vice versa. So the first thing in the file is an integer. So the first thing we want to read using the file scan format function is an integer token. And this represents the number of participants in our little contest. Then we can initialize I. And run our loop as long as I is less than the number of participants, and increment by 1 each time. Then we're going to read in the other parts of our file. For each participant, so for 5 people, there are 5 lines. Each line contains a string and an integer. So for each participant, we want to read in a string, and then we want to read in an integer. So for each participant, for each person in our file, we're going to read the name and the miles that they ran. So it's going to be name and miles. Then we want to print the bar chart. So we're going to print to our output file their name, and then the symbols that represent the number of miles that they ran. So we're going to have an inner for loop whose only job is to print whatever symbol we've chosen to represent each mile. And after we've finished, we're going to print a new line character. So for each participant, for each person in our file, we're going to read in their name, we're going to read in the number of miles that they ran, we're going to print out their name again, and then we're going to print a symbol for each mile. So if they ran 2 miles, we'll print 2 symbols. If they ran 5 miles, we'll print 5 symbols. And at the end, we'll print out a new line character. Before we finish, we're going to close both files by passing the file pointers to the fclose function. Okay, and now we're ready to see how it's working. We're going to build and run. And remember, since we're only printing to the output file, we're not going to see anything in our run window except that the program ran. Then we'll open our output file, and we'll see now our new output version that has each person's name and a symbol for each mile that they ran. Here we can look at them side by side. We can see that a side effect of using names is that our bar chart is no longer aligned. So it almost looks like Meredith ran more than everybody else, even though Erin has the most number of miles. So if we'd like to fix this, we can specify how much space we would like each of these to take up. And this is a output formatting that we haven't looked at yet. We've looked at how to control how many decimal places we print out, but we can also control how many spaces a field uses. So we can go here to this string and say that we want everything we print out to take up 9 spaces. And that way, when we print it out, everything will take up the same number of spaces, although it will be right aligned. So here's the new version. Everything is aligned. Everything takes up exactly 9 spaces. But it is right justified so that everything kind of meets here in the middle, all of the names and all of the charts. But I think it looks kind of cool. Another thing that we can use strings for is to specify the file name. we might not know ahead of time that our file is called names.txt. So instead we can ask the user to supply that for us. We'll need to create an additional string. We'll call this one file name. And then before we open the file, we'll ask the user for the file name. And this is something we can keep doing until we successfully open the file. One thing about pointers, remember pointers point to memory addresses. So if they don't point to anything, they're said to be null. A null pointer is a pointer that points to nothing. So we can say, as long as we don't have a value for our input file pointer, ask the user what is the name of the file, and scan in from the keyboard a string that we put in file name, and then we'll attempt to open the file from file name in read mode. And this way, if we're successful, then IFP will equal the pointer to that file. But if not, it will continue to be null, and so we can keep asking for a new file name until we successfully open the file. So let's do that real quick. See, now when we run the file, it's going to prompt us what's the name of the file. Ours is called names.txt. So if I type in the name of the file, names, and the file extension .txt, it should run, and we should get the same output as before, since we're printing to the output file. So that hasn't changed any. But now, if we run it and we give it something that, say, doesn't exist, it won't be able to open the file, and so IFP will remain null, and it'll prompt us again for the correct name of our file. So that's a great way to still be able to use input files even if we don't know ahead of time what the actual name of the file is going to be. We can simply ask the user using a string. In our next chapter, we'll start looking at arrays, which are collections of basic data types like characters, floats, doubles, and integers. I will see you then.